Hello everybody. Today's lesson is the last part of moments. Okay, today is the evening one. This is the last stretch. Okay, stay on. Okay, last stretch of turning effects is on stability 5.4. Okay, stability. In the textbook or in this topic, we are referring to stability as the ability to return back to the original positions after an object has been slightly tilted. So which means there will be several cases whereby the object, once I tilted, is able to return back, and that's what we call a stable equilibrium. If I tilt the object and it don't return, it just topple. Okay, that's what we call unstable equilibrium. And there is one last situation whereby actually I tilt the object and it actually just behave as per normal. Okay, we'll look in detail. Okay, one of the common example is when you try to push a wheel. Okay, we push a wheel regardless of how much it has tilted. The orientations or even the CG is always at the same position, and that is what we call a neutral equilibrium. Okay, we'll look at all these three types of equilibrium in details later on. Okay, now these are the three equilibrium that I mentioned, whereby it's stable. Means if you actually push this ball further up, the ball, and you let go, the ball actually will drop back. Okay, he's able to return to his original position, and this is what we call a stable equilibrium. On the other case, let's say if you push this particular ball down, you will actually just keep rolling down and falling down, and this is what we call a unstable equilibrium. He is unable to return back to his original position. Okay, the third case that we have for neutral, as I mentioned, okay, if you keep pushing this particular ball, okay, whether it's to the right or to the left, you find that it is actually at the same orientation. Okay, and this is what we call neutral equilibrium. Okay, in O-level physics, the type of question that the students will usually see is daily applications, whereby the objects or a certain scenario is given to the students, and the students will actually need to deduce which equilibrium the object is and deduce the possible outcome, whether it topple, return, or is neutral, followed by explaining that particular situation, okay, using keywords. Okay, we'll look at the first situation, stable equilibrium. Okay, before I tilt, okay, and after I tilt. Okay, by logic or by common sense, you'll find that when I tilt, okay, this particular cone, okay, will actually fall back, okay, and return back to its original position. That's what we mean by common sense. But how do I explain it in terms of physics? How do I write up such that the students can actually score the marks given in O-level, okay, to convey the same understanding? The explanation, what I did was I actually structured it in terms of the concept moments, and it actually uses moments. Okay, so moments is equal to force times the perpendicular distance. Okay, so what I actually encourage students is actually to follow this formula, meaning, okay, let's take a look. Okay, so what I actually tell them is the students must actually examine the situation by identifying what is the force, what is the particular perpendicular distance, which means students need to identify the pivot, okay, and after that identifying the particular or the resultant moments, and that moments will actually decide whether the particular object will topple or it will return back to the original position. Okay, let's look at how we try out. Okay, for stable equilibrium, let's say for this particular object, okay, when I tilt it to the side, okay, you'll find that it's actually pivoted at this junction, what we call point C. This is actually the pivoting point, the pivot. Okay, so what we have is the force that pushes this. Let's say I just tilt it to the right. Okay, I tilt it to the right, and after that I let go. Okay, so the only force that exists or that is left on this object, that acts on this object, is only one. That is the weight of the object. Okay, so the force that we are looking at is actually the weight in this case. Okay, so this is what we call the weight. Okay, and the first thing that students need to write is to identify the force in a particular format. So what is the format? Is the student must make reference to the base area. Okay, the force must be within or within or outside the base area. For this case, the base area for this particular object actually lies here. This is the base area. Okay, so it actually lies inside the base area. Okay, so the keywords that you're looking for is actually within the base area. After that, okay, you look at the perpendicular distance. Okay, the perpendicular distance is from the weight or from the force to the pivot. Okay, and the shortest distance between them. This is the d perpendicular distance that we are referring to. Okay, because there's a force, there's a pivot, there's actually what we know as a perpendicular distance. Okay, so we covered force, we covered perpendicular distance, and when you have force and perpendicular distance and you have pivot, these three components will actually give rise to the moments. Okay, and the moments, what it does is you have a force, okay, and you have perpendicular distance, and you pull down, you'll find that the object actually has experienced a moment which is in this particular direction, okay, which is what we call anti-clockwise. Okay, so this one is out. So these particular anti-clockwise moments will actually cause the object to actually go back to its original positions. Okay, so if you look at the keywords that we are looking at for this particular answer, okay, you will look something like this. Okay, so the students will need to write the keywords, okay, in this way. He or she will need to identify the force, okay, the location of the force, whether it's within or in this case within the base area, followed by telling the marker that there is a perpendicular distance, okay, followed by identifying the correct moments. In this case, it will be the anti-clockwise moments and the correct outcome, which is going back or returning back to the original position. Okay, which follows the formula Fm equal to F times D. How about the second situation when it's unstable equilibrium? Same thing, when I tilt the object, okay, the pivoting point is here, point C. This will be the pivoting point. Okay, once I let go, the only force experienced by the cone, okay, that will decide whether it topple or it return back is only one, the force here, which is the weight. Okay, so the force that we are referring to is actually known as the weight. Same thing, once you identify the force, okay, you need to tell me that the location, whether it's inside or outside. In this case, because it's a sharp corner here, the base area is only this small particular area, this small space here. So the weight is actually what we know as outside the base area. Okay, and you have a force, you have a pivot, okay, you have what we know the perpendicular distance. Okay, so this is actually the perpendicular distance, okay, from the force, which is the weight, to the pivot itself. Okay, so once I have force, I have a perpendicular distance. The relationship between them will be moments. Okay, the force and perpendicular distance at these instances actually causes the object to rotate clockwise. Okay, so the moments that you need to tell, students need to tell the marker is actually the correct moments, which is clockwise moments. Okay, and after that, the correct outcome. Okay, the clockwise moment will actually cause the object to topple. Okay, it will not go back to the original position, So which means for the full set of answers, it actually looks, the students will actually need to write in the same format again, okay, and it should actually cover this stuff, this particular area, which you need to cover the force, okay, the location of the force, perpendicular distance, the relevant moments, and the relevant outcome. Okay, if the students have all what we call the 4 keywords in his or her answer, you actually get a marks that is allocated for this particular answer. Okay, for neutral equilibrium, nothing really fanciful. What you actually have is that no matter how I push the object, okay, whether I push left or push right, for example in this case, whether I push right or push left, you'll find that, okay, the point of contact, there actually isn't much a pivot, because the whole section here is actually in contact with the surface. Okay, so there isn't any rotations or there isn't any moments, okay, because the pivot is actually one big area here. Okay, it's in contact. Okay, and as a result, you'll find that the force, or to be exact, the CG, okay, is actually always at the same level. Okay, whether it's before displace or after displace, is always at the same level. As a result, you will find that, okay, the weight, okay, about the pivot, okay, is actually 0. Okay, so it will not actually create any moments that will actually pull the object clockwise or anti-clockwise. Okay, or sorry, clockwise or anti-clockwise. Okay, there won't be any moment, and as a result, you actually will not see any toppling, or you will not see any returning to original position, because this particular object has not been tilted at all. Okay, for this particular situation, this is what we call a neutral equilibrium. Okay, this is the third case if you talk about stabilities. Okay, in a nutshell, okay, we have different scenarios. The best case will be stable equilibrium. The worst case will be unstable equilibrium. So how do we move from unstable equilibrium to stable equilibrium? There are two particular ways. Okay, there is as simple as it is lower the CG as possible. Okay, is you load the base, you load the object such that the CG actually is lowered, okay, to be a lower position as possible. For example, okay, let's say if I have an object, okay, what I want to do for this particular object to make it stable is actually I will increase the weight at the bottom. Okay, what does it does when I load the bottom of the object? Oops, sorry about it. Okay, is that you will find that the CG, okay, once I loaded, the bottom side now is heavier, so which means the CG actually will need to come down a little bit lower, okay, such that at this new location, the weights at the top and the bottom is actually balanced, and this will be the new center of gravity for this particular object, and because of that, the stability of the object has actually increased. Okay, that's what we mean by the first point. Increase the base area. For example, let's say my object is this. Okay, the base area is only so small. So how do I make it more stable? I will actually increase the base area, okay, such that the base area is wider, and because it's wider, it's actually occupying a larger space, and as a result, it's actually more stable as compared to the previous location here. Okay, so these are the two common ways that I can actually increase the stability of the object. Okay, that's why sometimes we have racing cars, actually the base is actually lowered and the base of the car is actually wider. Okay, to make the racing car stable, so that when the car make sharp turns, it actually doesn't topple. Okay, and with this we come to the end of the last topic of moments, stabilities, and this actually marks the end of this particular topic. Okay, same thing after the 4 videos, okay, that you have. Please run through your notes and textbooks, okay, to get a clearer understanding or the better understanding. Okay, and after that, work on your questions, okay, work on your tutorials to have a better or clearer understanding of the applications of the keywords and even the concept itself. Okay, hope to see you soon. Bye bye.